Hello. So now the video series about the operating system takes with the next topic of the CPU scheduling. In that we are going to look on into the FCFS and SJF. So in this video we'll see first with the FCFS, which is called as the first come first serve scheduling, and later in the next video we'll see about the shortest job first, which is shortly called as SJF. Okay, so coming on to the first come first serve scheduling, as the name implies, it means that whoever comes first to the CPU, that process will be executed first. Whether it is having the longest burst time or it is having the shortest burst time, that doesn't matter. Here it goes with whichever process comes in first, that process will be scheduled inside the CPU. So let's take an example over here where we have three processes. Process 1 with 24 burst time, process 2 with 3, and process 3 with 3 again burst time. But here the order of incoming process is P1, P2, P3. And this particular process is given inside the operating system, and now it has to schedule it and give the CPU for execution. So as per this first come first serve, the P1 will enter into the CPU first with a 24 burst time. After its completion, the P2 continues with the P1, and after P2, P3 completes its execution. So let's see another example how the process are taken for the first come first serve scheduling, and how we are going to calculate the waiting time and average waiting time, turnaround time and average turnaround time. Let's go with the example. As we explained the theory part of the scheduling algorithms, now we look back into the practical portion where we are going to see the problem of the first come first serve. So let's take an example of the given processes P1, P2, P3 with a given burst time in milliseconds as 7 for P1, 5 for P2 and 3 for P3. So let's start doing the Gantt chart. So for drawing the Gantt chart, we'll start with the process P1 which comes first. So P1 started at the arrival time 0 and the burst time of P1 is 7 milliseconds. So P1 executes for 7 milliseconds. Later the second arrived process is P2. P2 gets inside and the burst time of P2 is 5. So 7 plus 5 gives us 12 milliseconds. And after P2, the next arrived process is P3 that has the burst time of 3. So 12 plus 3, 15. So this is the Gantt chart for the first come first serve scheduling. Now calculating the waiting time. So the waiting time for individual processor, for P1 it didn't wait for any time. In 0 millisecond it started its execution. So for P1 it is 0 milliseconds. For P2 it started at 7 milliseconds. So the waiting time for P2 is 7 milliseconds. And for P3 12 milliseconds. So now computing the average waiting time. The average waiting time can be computed by adding all the waiting time of the process divided by the number of processes. So the waiting time of P1 plus waiting time of P2 plus waiting time of P3, the number of processes 3. So hence this yields 0 plus 7 plus 12. So that gives you 19 by 3, which is taken as 6.3 milliseconds. So this is the average waiting time for the first come first serve scheduling. Now we will compute the turnaround time. Turnaround time is the time taken for completion of the process after its execution. So now the turnaround time can be taken as the time for completion of P1, P2 and P3. So the turnaround time for P1, it took 7 milliseconds for completion. So 7 milliseconds. For P2, it took 12 milliseconds for completion, and for P3 it is taken as 15 milliseconds. So finally, now the average turnaround time can be computed as sum of the turnaround time of all the processes divided by number of processes. So that gives you 7 plus 12 plus 15 divided by 3. So that is equivalent to 27. 34 divided by 3, which is equivalent to 11.3 milliseconds. So now this is the total turnaround time or the average turnaround time for the given set of processes in FCFS scheduling. Thank you.